Alright, this is part 2 of the review for Chapter 4, Honors Chem Review, so this should get you all set for the test on Friday. Here's what you have to remember. This is about isotopes and isotope calculations. First and foremost, what you're going to need to remember is we measure atomic mass. The definition of it, we're going to ask this on the test, is it's considered to be 1/12 the mass of a carbon atom. So basically, carbon-12 isotope is considered to be very pure, so carbon-12 was chosen. So since it has think of it like this, it has 6 protons plus 6 neutrons, total of 12 atomic mass units in its nucleus. The definition of AMU, or atomic mass unit, is based on carbon-12. Okay, so when we look at the periodic table, you'll notice the values in the periodic table that are for each individual element are expressed as decimals. That's because they're averages, kind of like your GPA. If you look at your GPA is an average of all your grades divided by 7, and that's how you get it each semester. Same idea with an isotope. So let's talk. Isotope. The definition of isotope is the same element. So it's the same element, same number of protons, just different numbers of neutrons. Guaranteed I'm going to ask you that tomorrow. So if you look here, hydrogen, these are all isotopes. Notice hydrogen 1, 2, and 3. Notice if you look right here, you have a 1 proton, 1 proton, and 1 proton. What makes the different hydrogens different from each other is the number of neutrons. First one has 0 neutrons, the second one has 1, third one has 2. So that's how you end up with hydrogen 1, 2, and 3. Lithium. If an atom is lithium, if you look at the periodic table, it means it has 3 protons, right? So you got 1, 2, 3 from the periodic table. You got 1, 2, 3 protons. If you take a look at the periodic table, all of lithium has 3 protons. In this case, it has 3 neutrons. In this case, it has 4 neutrons. That's why they're isotopes. Now, here's an example of sodium. Sodium has, if you look at the symbol, always has 11 protons. But can have sodium 23 and sodium 24. Well, the difference is 12 neutrons in that one, 13 neutrons in that one. So if you're asked on the exam or the test to find pairs that are isotopes, keep in mind, like for example here, you have carbon-12 and carbon-13. Let's take a look at what's similar and what's different. They have to be the same atom, so they have to have the same exact atomic number, and they have to have the same symbol. The thing that's going to be different is going to be the different mass number. So if you're asked to spot an isotope, remember the bottom number has to be the same, or the symbol has to be the same. The top number has to be different. That's the key to spotting it on a test. Now, one of the things we do is we have to calculate average atomic mass. How do we do that? I'll show you in a problem. Basically, you'll be given AMUs in a problem, and it's just AMU times its percent. Here's what you have to keep in mind. You have to change percent to the decimal value before you put it in your calculator. I call it P to the D, percent to the decimal. So percent to the decimal, the P to the D, P to the D. So every time you plug in a percent here and a plug in percent here, it has to be adjusted or divided by 100. It's the easiest way to do it, or bounce a decimal to the left 2 places. So then when you go to set it up, all you're doing is multiplying 2 numbers, multiplying another 2 numbers if it only has 2 isotopes. You add them all together and you get the average atomic mass. You don't have to divide by anything. All you're doing is making sure you put the P to the D, the P to the D. So take a look at this problem right here. See a problem? We have a whole bunch of masses. The masses of the AMU never changes, but the percent abundance has to be adjusted. These all have to be adjusted by the P to the D. So what are we going to do when we do that? You're going to bounce the decimal over 2 places or divide by 100. So like 5150 is going to be 0.5150. 1120 is going to be 0.1120. 0.1710. You get the idea. This is what it looks like when you're all done. You notice all the percents haven't changed to decimals. Once you do that, then you just multiply the 2 numbers. So you're going to multiply these 2, you're going to multiply these 2, so on and so forth. And the last step, after you multiply them, here we go right here. These are after the AMU times the percent, change to a decimal, P to the D, you get this number this number, that number, and that number. The last step is to add them all, sum them up, and you get the average atomic mass. So if you look right here, you sum them all the way down, and you get 91.32, and that represents the average atomic mass because all the isotopes for that element have been sorted, their percent abundance has been determined, their mass has been determined, and this is how you mathematically do it. So keep in mind, your setups are always going to be the same. You just have to, only thing you have to do is adjust that, and then it's multiply, a bunch of multiplication, and add together. That's all you have to do. P to the D. Here's some sample problems from the optional review. In this problem, they're asking you to identify who are the isotopes. Remember, isotopes is the same element. So when you look, remember the symbol has to be the same, and the atomic number has to be the same. The difference would be the mass number is different, and you notice the mass number is different there and there. So that's what makes A the correct answer, because the definition of an isotope is the same element, different mass numbers. Which pair of symbols represent isotopes here? Well, if you notice, these are different elements, so it can't be that. This one, I have oxygen and oxygen, and the mass numbers are different. The symbols have to be the same. They're not showing the atomic number. That's what makes B correct. Why is D incorrect? Because this is an ion, not an isotope. You don't have different mass numbers listed, so that's why that can't be the correct answer. These are two different elements, so obviously they can't be isotopes. Here's an isotope calculation problem. Just remember this, the P to the D. So when I first start, I identify the relative abundance. I figure out which one I have to adjust. This is AMU, so I'm good to go. So this is going to end up being 0.77422, 0.1278, 0.1300, and then I do my math. I'm going to multiply these, get each of my answers, and add them up at the end. The key to doing an isotope calculation, you're going to have to definitely do one or two on the exam, is just finding the percent and changing it, or also called the relative abundance. It's the same thing. Here's a couple other questions that come up a lot of times on here. It says, what is the mass number of an isotope of lead? As soon as I see the element, the first thing I'm going to do is go to the periodic table and verify the number of protons. So I'm going to basically go to the periodic table. I realize that lead has 82 protons. They're asking me for mass number, which means that C can't be my answer. So then once I have my number of protons and I verify it, every time I do that on the periodic table, I know that the mass number is protons plus neutrons, so 82 plus 126 is going to give me a 208 value right there. Next one, how many neutrons are there in a nucleus of a 108 silver atom? First thing I do is I go to the periodic table for silver. Silver's atomic number is, hold on, I gotta reset the page. Silver's atomic number is going to be, when I look it up, it's going to be 47. That's the number of protons it has. They're asking me neutrons. So then once I find 47, whenever I have to find neutrons, it's always going to be the larger number, which is always going to be the mass number. 108 minus 47 is an easy way to do it, and then I can easily figure out or solve the answer in that case. Next question is asking me how many protons and neutrons are there in sulfur 33. The first thing I do is I go and look for sulfur on the periodic table and find the number of protons. Sulfur has 16 protons, which automatically means I eliminate D as an answer choice and I eliminate A as an answer choice. So then it's a matter of then looking at just by the number of protons. I usually on a lot of these questions I can narrow it down. Obviously if the mass number is 33, it means protons and neutrons. That's why C is going to be my correct answer. So keys for the test tomorrow, use your periodic table. It's going to provide you with the atomic number. The atomic number is the same as the number of protons. It's key for answering any of these proton neutron questions. Makes it a lot easier, especially when you're trying to find mass number and stuff like that. Helps you organize your thoughts. Good luck. If you have any questions, go ahead, email me. Otherwise, good luck on the test tomorrow.